All right, so this week, Monday, Tuesday, Wednesday, we're going to focus on what's called parametric and polar graphing. Thursday is going to be a little different. That's on what we call conic sections. There is a connection between that and what we're doing, but we're never going to look at the connection between the Thursday material and the stuff from earlier in the week. We're not going to get into it. So Thursday is going to feel like it's kind of separate, its own kind of thing. Also, Thursday is going to be out of a packet. Okay, the same kind of packet I gave you on vectors. It's a different packet, but it's that same book. This material up till Thursday is in your book. So with parametric graphing, you can get some different kinds of graphs, right? Things that maybe would be very hard to draw with y equals. Just some things that even are the same, but maybe it's easier to draw them. So you can get shapes like that. You can get one like that kind of looks like a butterfly. Some of these are a little more complicated than we're really going to get into. We're going to look at spirals. Those are pretty simple. We're going to look at like petals. Like you can have like a certain number of petals, like on a flower kind of thing. But that butterfly one, that's pretty complex. That might be something we would look at too, like the first and the last one. It's a little simpler than the one in the middle. Okay, those are all different kinds of parametric graphs. Has anybody ever done anything with parametric graphs before? Okay. So, first I'm just going to kind of explain what parametric is, and then we'll do some stuff on the calculator. So, first thing is when you're doing something parametrically, it involves having two functions. Okay, two functions. So if let's just go like this. Put it on y equals. Every color there is a different graph, right? You just have to type something in on that one line, like that top one, and you'll get a picture in blue. Okay, you just type in one formula. Now, let's look at what it looks like in parametric. Let's go like this. All right, so now compare that to this one. If you want to graph something in blue, you have a formula you type in here and another one you type in there. The first formula has something to do with the x values, and the second formula is for the y values. So I'm going to go through it, but I'm just kind of showing you on the calculator. There's two formulas per color, okay? Because you got to type two. And you can call the formulas whatever you want. I'm just calling them F and G. Now, we're going to talk more about this interval. But basically, this interval, it's going to give you a starting point and an ending point, and it tells you what numbers you are allowed to plug in. So as an example, when we do this problem, there's a formula for x, there's a formula for y. And the letter they use is t. Now, technically, you could plug in anything you want for t, but they don't want you to. They only want you to plug numbers in between 0 and 1. Why? Well, that's the problem. That's what they want you to do. So you're always going to be given an interval for what you're allowed to plug in. So we'll talk more about that interval later on. All right, so basically the way this works is the first formula, you're going to plug a value into it, and whatever you get for an answer, that's going to be the x value of a coordinate. The second formula, you're going to plug a number into it, you're going to get a value, and that's going to be the y value for your coordinate. So the big difference between the kind of graphing you're used to doing and parametric is you have two separate formulas. One formula controls the x values, another formula controls the y values. We're used to one formula doing both. Okay? Now it's separate. It's the only difference. So if you take all the different points and you draw them, you put them all out. Eventually you have so many points together that it just looks like a solid picture. Maybe that's like an arc or something. Well, the shape that you get when you draw something parametrically is called a curve. Any kind of graph on the screen is a curve. That's a parametric curve. That's another parametric curve. That's another parametric curve. Even if I had something like this, that's considered a parametric curve. Curve doesn't mean that it actually has like a bend in it. A curve is just what they call the picture of something drawn parametrically. Whatever the picture is, curved or not curved. Okay? They call it a curve. That's the name. So, the two I mentioned up here, you have two formulas or two functions for every problem you do. One formula gives you the x's, another formula gives you the y's. And those two equations together are what you call parametric equations. One equation will always be x equals, the other one will always be y equals. And notice the letter that they use, t. T is like what you would plug in for. Maybe you plug in 3 for t or 4 for t. You just plug in what they tell you to plug in. And if you're wondering, well, how do you get the t on the calculator? Once you change to parametric, put it in parametric mode, this used to be the button that you would press for x. Well, now when you press it, you get a t. So this button does 4 different letters, and it says them right on it. It does x, t, theta, and n. When it's in parametric, it gives you a t. Right? So those two equations are called parametric equations for the picture that you drew. And t, they don't really call it a variable. Okay? They give it a different name. They call it a parameter. Okay? You can think of parameter, it means the same thing as a variable. Really. Okay, so t is the thing that you're going to plug in for. If you call it a variable, it's not a big deal. But technically, it's called a parameter. Okay, so a little bit of vocabulary stuff up front, but then we're going to get into some more just like calculations. Any questions on those terms so far? All right. So one kind of big difference about parametric graphing and the kind of graphing you're used to doing is parametric curves usually have a start point and an end point. They don't go on forever. So if you had a spiral, if you watched me draw it, you know where I started. If you didn't, you don't know where I started. Maybe I spiraled in, or maybe I started at the middle and I spiraled out. But the point is, you can see there was a start point and there was an end point. Now, sometimes it's hard to see the start point and end point. If you have a parametric graph that connects back to itself, like a circle, if you didn't watch me draw that, you can't really tell where I started and stopped. I mean, you kind of can, because I didn't draw it perfect. But if I had drawn it perfect, you wouldn't really be able to tell, right? So a circle can be kind of hard to see the start and stop. But technically, it still has one. And what's going to control where a parametric graph starts and stops is the parameter. It's the t. And you're not going to really have a choice what t is. They will tell you what they want t to be in the problem. Right, so suppose that they tell you, okay, you are allowed to use the numbers from A to B. Right? In a real problem, it might be something like this. You are allowed to use the numbers from 0 to 1, and you can plug them in for t. Right? They'll tell you where they want you to start. They'll tell you where they want you to stop. Okay, to find the coordinates of where the parametric curve starts and stops, there are 4 calculations you have to do. You have to find a starting x value and a starting y value. Then you need an ending x value and an ending y value. this number right here controls where your curve is going to start. This number controls where your curve is going to stop. So again, A and B will both be numbers. Plug A into the formula for x. That'll give you the starting x. Plug A into the formula for y. That'll give you where the starting y is. Now you've got a coordinate. Now do the same thing with B. But B controls where the curve ends. Plug B into the formula for x. You'll get an ending x value. Plug B into the formula for y. You'll get the ending y value. Now you've got an end coordinate. Right, so that's all we're going to do to kind of start. I'm just going to practice. I'll give you a curve, and I just want to know where it starts and where it stops. Now, just because you know where it starts and stops, that doesn't make it easy to draw. Okay? So if you start and stop, maybe it's connected with a straight line. Maybe that's a arc. Maybe it does something like this. Could be a spiral. It does something like this. Who knows? But just because you know where it starts and stops doesn't tell you how to draw it. That's a little more involved, and we're going to use the calculator for most of that. Okay. So here's a set of parametric equations. We got one formula for x. The formula is 1 minus 2t. And a separate formula for y. 2 minus t. Okay. And they will always tell you what you are allowed to use for t. In this case, you are allowed to use from 0 to 1. Now, this goes back a little bit, but there's brackets on the 0 and the 1. Do the brackets mean I can use the 0 and the 1? Yes. Or I can't? I can, yes. So I can go right up to 0 and right up to 1. Okay. So I'm not going to sketch it. Maybe I will on the calculator, but all I want to know is tell me where the curve starts, tell me where it stops. Okay. Let's find the coordinates of the start point. So the start point is going to have an x starting value and a y starting value. Okay, let's begin with the x. What number here, the 0 or the 1, is going to control where things start?
0.
The 0. So you're going to take the 0 and you're going to plug it into both of these formulas. Plug 0 into the x formula. And let's see what we get. So replace t with 0. 1 minus 2 times 0. And what does 1 minus 2 times 0 give me? 1. So as far as where this graph is going to start, it's going to start at 1, comma, something. We need the y value. Take the formula for y, plug in 0. You're not using the 1 yet. The 1 is going to tell me where it ends. The 0 tells me where it starts. Plug in 0. 2 minus 0. So where does this? Where does the y value begin?
2.
2. And that is your starting coordinate. 1, comma 2. Okay. Any questions on that? Okay. Now we're pretty much going to do the same thing to find the end coordinate. But we're not going to plug in 0 for x and plug in 0 into the formulas. What will you plug in? 1. Yep. Let's plug in 1. So m. You got to find an x. You got to find a y. Okay, so take a second and see if you can figure out what do you get for the x value when you plug in 1. Where's that 1 coming from? Right there. And then tell me what you get when you plug in 1 into the y formula. So, Alec, what do you get when you plug 1 in to the x formula?
You would get 1 minus 2 times 1. So
Yep, 1 minus 2 times 1, which is
negative 1.
-1. Okay, so this graph is going to end at -1, comma. Now plug 1 into the y formula. 2 minus 1. 2 minus 1, or 2.
2 minus 1
Is 1. Thank you. 2 minus 1 is still 1, even on Monday.
Yes.
Okay, any question on that? Now, when we've done a lot of graphing all year. When you graph on the calculator, what direction does it always draw? From what to what?
Left to right.
It always goes left to right. Have we ever drawn a graph all year that's gone right to left? No. We never have. So look at where these points are, just roughly. 1, 2. 1, 2. So you're starting here. And your graph is going to end at left 1, down 1. Left 1, down 1. You're going to end here. So when the calculator draws that, is it going to draw it left to right? If it draws it correctly? Okay, good?
No.
No. This is actually going to draw it right to left. The calculator will draw it whatever direction it's supposed to. Now, does that make a difference when you're looking at the final picture? Not really. Whether it started at A and went to B, or B and went to A, it's going to be the same picture. But the calculator will do it properly. All right. So I'll type one in just to show you, but we're going to do a lot more later with the calculator. So x is 1 minus 2t. So put that in. Y is 2 minus t. And you got to have both. If you leave one of those formulas off, your picture will be blank. Okay, so you put both of them in. Now we've got to set this domain. Okay, there's a spot for that. It's under the window. So when you go to window, you still have the x min and max and the y min and max. That's all the same, but you got something extra. T min and max. T min in this case is 0. T max is 1. That's where you type that in. 0, 1. Don't worry about TStep. I'll explain what that is later. For now, just put it on point 1. Now, this window is kind of big. I mean, it's going -10 to 10. You really don't need that big of a graph. I think you could go like -3 to 3 on every direction. And then you'll see a little bit more zoomed in picture. So let's do that. -3 to 3. -3 to 3. Now, when you watch it, if you want to see it draw from right to left, you have to kind of watch it as it's doing it. So it's going to start in quadrant, what is it? Quadrant 1, and it's going to end in quadrant 4.
And in quadrant 3.
Did I put in... Oh, it's not -1, -1. It ends at -1, +1. I put -1, -1. So it did do it correctly. Okay? And it drew right to left. Yep.
What are you doing the calculator again?
So that's parametric. So under mode, you put it in parametric. Okay. And this one happens to be a simple line segment. Not a line segment. Any questions on that? Okay, so that's how you figure out where a parametric curve starts and stops. Now, sometimes, not all the time, but sometimes it's possible to take an equation like we just had and turn it back into the kind of formula we're used to, right? We could take what we just had and make it like y equals mx plus b. That process of changing it back to what we're used to doing, that's called eliminating the parameter. What letter are we using for the parameter in parametric?
T.
T. So the goal when you're eliminating the parameter is to write an equation that doesn't have a t in it. You get rid of the t. Okay, so sometimes it's possible to eliminate the parameter in a parametric problem and just describe what your picture is in terms of an x and a y only, like y equals 3x plus 7. No t. Okay? Sometimes. I won't give you a problem and say eliminate the parameter if it can't be done. Okay? If I ask you to eliminate the parameter, it'll be a problem you can do. Or that is capable of being done. If you can do it, we'll see. This is usually pretty easy. Okay, it's not. I think you won't find this is bad. So let's take the example we just had. X was 1 minus 2t, and y was 2 minus t. And I want to eliminate the parameter. Okay. So when I'm done, let's go back and look at the picture. That's a line segment. What's the formula that you usually use for the equation of a line? It starts out y equals mx plus b. That's what I want to get when I'm done here. Are you always going to get a line? No, this one's not a curve. It's a nice straight line. But the process of getting whatever it is you're going to get is exactly the same each time. So this equation right here, we'll call this one first one and the second one. The second one is almost what I want. It's y equals, but I don't want this t here. I have to plug in something from this for t. Where could I get some information to plug in for t? From where? From equation 1, yes. So what you want to do is get t by itself in equation 1. Do that first. So what's the first thing I could move to the other side to get t by itself in that equation? The 1. How would you move 1 to the other side? Okay. Good. Now, what number is in front of x? I didn't put it, but you could put what number there if you wanted. You could put a 1. Some people put that in, some people don't. Now I got to get rid of the negative 2. How would I get rid of that negative 2? Yep. And where would you divide? Okay. And when you say other side, where do I do it on that side? So I got to divide by negative 2. My question is, where do I do it? Very specifically. More specific than just saying on the left. Because if I just say divide by negative 2 on the left, that's right, but I think some people might not know exactly what I mean.
Divide negative 2 by 1x minus 1.
So yeah, you have to do it here and here. So divide by negative 2 everywhere. That's gone. So now you get t equals, you can think of that as negative 1/2 x. That's what that really is. Negative 1/2 x, and negative 1 divided by negative 2 plus 1/2. Now you've got something for t that I can take and go like that. What's that called when you, there's a name for this, when you solve, you basically get one letter by itself and then put it in the other equation. Substitution. That's all you have to do to eliminate the parameter. It's something you've already done. It's substitution. Get t by itself in the x equation. Step 1. Step 2, plug in for t in the y equation. Now let's do that. Y equals 2. And anytime you substitute in, always use parentheses because watch what's going to happen with that negative. 2 minus t. 2 minus negative 1/2 x plus 1/2. What do I have to do with that minus that's in front of the parentheses? It has to be distributed. And once we do that and combine like terms, we're going to have y equals mx plus b. So y equals, what's negative negative 1/2.
1/2 x.
1/2 x. Now let's do this at the same time. We have 2 minus 1/2. What's 2 minus 1/2? 1 and yeah, you could write 1. You could write 3 halves. You could write 1.5. Either way, as long as you understand 3 halves is 1.5. And there's your equation. So what we just did is we took something that was parametric, got rid of the t. Now you have a function. Y equals 1/2 x plus 3 halves. So let me draw that, compare it to what we just had drawn before, and see if they look the same. I mean, they should. We did all the algebra, right? So let's take, here's your picture parametrically. And let's go back to function. And what was it again? 1/2 x
Plus 3 halves.
plus 3 halves. I'll just do 1.5. Now, in order to compare this accurately, you need the same window. Okay, same window on the left and on the right. And I have the same window. Okay. Do those pictures look the same?
Yeah.
The segment of those on the segment that exists on the right graph, yeah.
Okay, but are they the same picture exactly?
No.
No, not quite. What we want is just the section between -1 and +1. That's what you want to draw. So why didn't the calculator do that? Because we didn't tell it to do that. We told it to draw the whole line. So what you have to remember is once you eliminate the parameter, next to it, you need to tell me what should I draw between from here, from where to where. Okay, so remember the original parametric thing that you drew was just a small section. So we have to restrict the domain. Okay, and remember, when you restrict the domain, that's just the x values. So what you need to put here is a lower limit and an upper limit for x. How do you know what they should be? Well, if you look at the graph, we already know it's -1 to 1. But what if you didn't have that picture? Well, then you would have to go like this. You would have to find the starting and ending x values only. Okay, when you're talking about limiting a domain, we don't care about the y's. So my starting x is 1. Now, one thing that's a little weird is when you find your starting x, that doesn't mean it's the biggest or the smallest. It just means that's where x starts. Here's where x ends. So in my case, was the starting x value the biggest x or the smallest x? It was the biggest. And my ending x was the smallest. Just the way it worked out. It could have been flip-flopped. Okay? But the point is, x goes from -1 to +1. Those are the numbers it's between. So, when you eliminate the parameter, you do two things. Tell me the formula, that's the hard part, and then tell me where to draw it. What should I stay between? Now, on the calculator, we can tell the calculator to do that. What you have to do is put that formula in parentheses, and then next to it, type this in. But you can't type it as a conjunction. You got to type it as two separate ones like this. X is greater than or equal to -1. That's the first condition. And the second one, x stops at 1. X is less than or equal to 1. So now you've told the calculator what to draw, and you've said from here to here. Now, that's the best I can do. I know it's not exact. There's nothing that I can do about this. The calculator, when you put it in function mode, it's going to draw everywhere. Okay? It can't help itself. Like, it wants to just draw everywhere. So the best I can do is just say, you know what, let it just put a line right here, but pretend that that's not even there. Okay, it shouldn't be. But that's all you can do. And now the picture here and here, now they look the same. I mean, one looks a little more jagged than the other. I don't know, it's just the resolution of the screen or whatever. But the point is the pictures look pretty much the same. Any question on that? Okay, let's try, I think I have one more, eliminate the parameter. Let's try this one. Okay, this time x is t minus 1 and y is t squared. And the interval, which in other words, these are the numbers you allow to plug in for t, is anything from 0 to 3. I mean, mathematically, could you plug in 4? Of course. You could do 4 minus 1 and get an answer, but they don't want you to. Okay? All right, so what's my first step to eliminate the parameter?
Find the start and end points.
We're going to need the start and x. We're going to need that eventually, but we can write the formula first. You can write the formula first and then tell me where the formula is drawn after. So how do we get the actual formula?
Y equals mx plus b.
So that's the goal. The goal is to get like an equation that's y equals. I will tell you this one will not be a straight line. So it's not going to be straight, but the steps are still the same. What's the first thing we did last time? Yep.
You got t by itself in the x equation.
Yes, step 1. Get t by itself in the x equation. Don't worry about if it's going to be y equals mx plus b. Who cares? Just get t by itself in the x equation. So what would you get when you get t by itself in the top?
Negative 1 plus x.
Or
X plus 1.
x plus 1, right? Plus 1 to each side. X plus 1. Now, what do you do with that x plus 1? This is the second step.
You substitute in the y equation.
Substitute it in the y equation for
T.
Yes. Take what you just found, plug it into t for the y equation. If you've done it correct, when you're done, t is gone. So we get y equals, and what am I filling in for t? X plus 1. That's fine to leave the answer that way. I would prefer that as the answer. In the book, maybe they would FOIL that out, which I'm hoping people, just if you FOIL it, that's what you would get. Okay. But I would just leave it as the first one. Now, what is that shape? X squared plus x plus 1 squared. If you draw that, I told you it's not a straight line. Yes, it's a parabola, specifically shifted 1 unit to the left. Yep, very good. It's a parabola shifted 1 unit left. But is it an entire parabola or just a small section? It's just a small section. How do I know that? They told me originally I could only plug in numbers between 0 and 3 for t. So here, I need to find the condition on x between what and what. Okay. Which value here? Well, we need to plug in both of them. Okay? Doesn't really matter where it starts and where it stops. All I really care about is get me the highest x value and the lowest x value. And use these two numbers to do it. Okay, so let's start with 0. If you plug in 0 for t, what do you get for x? Negative 1. I'm just going to write that off to the side. Now, what if you plug in 3 for t? What do you get? 2. So this time, the starting point gave me my lowest value. The ending point gave me the highest value. So we go from negative 1 to 2. So it's a parabola just between negative 1 and 2. Okay, let's see what it looks like. Now, I'm not going to sketch it as a function. I'm going to sketch it as the original problem. So I'm going to go back to parametric. And I'm going to put in t minus 1 and t squared. Now, before you hit graph, what other screen do I have to go to?
Window.
I got to go to window, and I got to adjust my t min and max. It's not 0 to 3. I mean, it's not 0 to 1. It's 0 to 3. Okay, let's leave the window at negative 3 to 3. If we see it go off the screen, we can adjust it. Okay. Let's go a little higher, because when you look at that, to me, you can't tell that it stops, but it does. Set your y max to like 5. Right? Still can't see where it stops. Well, eventually, it is going to stop. Let's set the y max at like 20. Okay, so I found it. It might take a little while to find it, but and 20 was probably too high. I maybe only need to go to like 10, 12. But the point is, now you can see where it starts and stops. So it's just a small section of a parabola, not the whole thing. Any question on that? All right, so sometimes it's possible to eliminate the parameter. Not always. If I gave you a problem like this, you could not do that one. That says x equals 3 to the t plus t, and y is t squared. It's not y that's the problem. It's x. And the problem with x is you have a t as an exponent, and you have a t as a term at the end. You can't have both. It's impossible to get t by itself. So you couldn't do a problem like that. But the ones I give you will, they're always doable. Now, you can only do what we just did sometimes, but it's always possible to go the other way. You could give me any equation you want, and I could make it parametric. Anything. You could tell me anything you want, and I could make it parametric very easily. And I'll show you how, like this. Okay, give me, somebody give me an equation that's y equals anything. Just make sure it has x in it somewhere. Yeah?
2 sine of x.
2 sine of x. Okay? We'll talk about what happens when you throw a trig function in parametrically. Not right now, but I'm actually going to do something just like that in a minute. So we got y equals 2 sine x. All right? Well, if I wanted to make that parametric, the first thing I'd have to do is I got to use t. Right? I can't use x, I got to use t's. So I could just say, okay, 2 sine t. But what did you say originally? T was supposed to be what letter? Okay. So say x equals t. So it's kind of, it's almost like cheating. But I just took what he said and made it parametric. How can you check it? Take this equation and solve it for t. It already is. T equals x. Now, once you get t by itself, plug that into this equation right here. You would get back exactly what he just told me. 2 sine x. So it's kind of a cheap way to make something parametric. All you have to do is let x equal t, That's the same every time. And then take the equation that the person gives you and change the letters to t's. That's all you gotta do. So take the equation you're given, change everything to t's, and then just write x equals t. And you got it. Okay, I got an example on the next page. Doesn't matter how complicated of an equation someone gives you. That's why I let somebody name anything they want, because it wouldn't make a difference what you say. Okay, so let's try it. Let's try it on this one. I want to write this equation parametrically. Now, you don't have to worry about the interval on this. Like t should go from 0 to 1. This kind of problem, you don't have to worry about that. Let's start with y. Anyone tell me what the y equation should be? Yep, Michael.
3t to the fourth plus 17 to the third minus 8t to the second plus 2.
Yep. Now, that equation that he just told me, that's not the original. The original has x's. So the t's should turn into x's. So what should I write for my top equation? What would be the whole thing?
T to the fourth.
Right here?
Or x equals t.
X equals t, yes. Now the way you can check it, do just like we've been doing. Take the top equation and solve it for t. It already is. Take what's on the other side and plug that in for all the t's. If you do that, you get back the original problem. So kind of a really cheap way to make something parametric, but it works. Any question on that? All right. So let's look and see if we can figure out how to draw a circle. Okay, nothing super fancy, not like butterfly craziness. Just like a simple, simple circle right at the origin. And the way to think about how to draw a circle is don't even think about the whole circle. Just think about a single point on it. Just picture one point on the circle in your head. Okay. So something like this. I just want to think how I could represent that one dot. So when you do something parametrically, you have two equations. What does the first equation represent? The what? Well, the start point is a combination of both equations. You need to use both. But what does each equation represent parametrically? One of them is this, one of them is that. Yeah? You can say it in one word. One of them is, the other one is.
I don't know, like, the one word, but, like, the x is, like, what you use to find, like, where you can, like, the boundary of, like, where you can go. Like, when you're coming up with the... I don't know how to explain it.
So when I showed you, like, think of, like, what it looks like on the graphing calculator. When you press the y equals button, you see two rows, right, to type something in. What does the first row represent? That is a formula for the what? For the x values. So if you want to write something parametrically, you need to figure out an x value. And what does the second equation represent? A y value. So to write something parametrically, you need a formula for x and a separate formula for y. Okay. Any question on that? Now, what do you think I could do with this picture? We do this kind of stuff all the time. Yes, we're going to make a right triangle out of it. Now that line that I just drew in black, what is that? Well, it's a couple things, but it's the radius. That's what I was kind of getting at. That's the radius. And now, what's this? Right there. In between the black side and the red side. That's my angle. Now, the angle can change, right? Think about it. If this point was up here, your triangle would be over here. That's a different angle. If your point was over here and you made your triangle, that's a different angle as well. That angle can change. So when we do parametric, what is the letter that we use for the thing that can change? T. That's what you call your angle. T. You don't call it theta. You don't call it theta because in parametric, T is the thing that can change. Think about R. R would never change. No matter where I put the point. Still R, still R, still R. Those are all R. But what's different with every single one is the angle. Right? Okay, so let's see if we can set up a formula involving T, X, and R. The side that I've labeled X, what position is that from the perspective of the angle? It's adjacent, all right? And what about the radius? That position of that is the hypotenuse. What adjacent over hypotenuse? When you see that, what do you think? Cosine. Maybe you think, oh crap. But no, you should think cosine, right? Adjacent over hypotenuse. So let's set that up. Cosine of my angle equals, and Jake just told us, adjacent was X, hypotenuse was R. Now, get X by itself, and you have one of the two parametric equations. What would X equal?
R cosine T.
R cosine T. Now, we could go through that again, but I think, can anybody figure out what Y would be?
R sin T.
Yes. And together, these are the parametric equations for a circle. You have to pick a value for R. You pick R to be whatever size circle you want, and then you type it in. Okay? So those are the parametric equations for a circle with the center at the origin. You don't have to worry about shifting it up, down, left, or right. Okay? So here's your two equations. Now I'm going to give you a problem, but I'm just going to tell you what I want R to be. Find the equation of a circle with radius 2. So what would be my equation for X? Just filling in that specific radius. Yep.
2 cosine T.
Perfect. 2 cosine T. And what about my equation for Y?
2 sine T.
2 sine T. That is the equation of a circle with radius of 2. Now, what's important here is the parameter. If you don't let the parameter go big enough, you won't get a full circle. You might get a half a circle or 3/4 of a circle. If you let it go too big, you're going to end up tracing over yourself, which isn't really a problem, but we don't like it to have to trace over itself. We just want it to draw it as quickly as possible. So think of sine and cosine. What's the period of sine and cosine?
2 pi.
2 pi. So that's what you have to let t go from. 0 to 2 pi. If you go any less than 2 pi, you will not get a full circle. Okay, let's draw this one, and this is where I'm going to point out to you what TStep does. Okay, this is a circle. Okay? So it's very important that it looks circular. Okay? You don't want it to look kind of like an octagon or something like that. You want the sides to look curved. So this is how you do it. 2 cosine t, 2 sine t. Okay, that's the easy part. Now the window. Well, we already said it has to go from 0 to 2 pi. I'll put it back at 3 in a minute. I'll show you what happens. It won't be enough. Now, this t-step, leave it at 0.1 for this one. That's fine. And you'll get a pretty good picture. Now, look at the shape of the screen on the calculator. What shape is the white screen? It's a rectangle. Rectangles are wider than they are tall. So what's going to happen is if you set the x min and max to -3 to 3 and y min and max to the same thing, your image is going to look distorted. Okay? That is a circle, and that is radius 2. Because if you look carefully, it goes 2 units in each direction. But if you want it to look proportional, just go zoom 5. And now it'll make it look more circular. Okay. So that's what it should look like. Let's change this t-step. Let's change it to 1. I'm going to hit graph and watch what it does. Okay, so what the t-step is doing is it's telling the calculator how often to graph points. So what the calculator does when it graphs things parametrically is it basically puts a bunch of points and then connects them in straight lines. If you put those points very close, then you get a smoother looking curve. Let's look at this one. You're starting at 0 and you're ending at 6.2, well, 6.3. And you're going by ones. So the calculator is going to plug in 0 for t, 1 for t, 2, 3, 4, 5, 6. So basically you're allowing the calculator to graph up to 7 points. It can't go past 6 because the next jump after 6, if you step by ones, is 7. 7 is too big. So the calculator is graphing 1, 2, 3, 4, 5, 6, 7. Now let's put in 0.5. Now you should get a better picture. Not that good, but better. It's going to graph 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, and that's it. So I think that's 13 points. With 13 points, you get a little smoother of a picture, but also notice this gap. That gap is there because you're trying to go to 6.28. You're counting by halves. So you get 5, 5.5, 6, but then there's nothing after 6. The next one would be 6.5. That's too big. That's why you try to make your t-step small enough that it gives you enough points that it makes it look good. But what you don't want to do is this. Okay, 0.001. What the calculator is going to do now is it's going to count from 0 to 6.28 by thousandths. 0.001, 0.002, 0.003, 0.004, all the way until it gets to the number 6.28. So now the calculator is trying to graph thousands and thousands and thousands of points. I mean, it's doing it, but if you look at it, it's going to take a very long time. So if you get into a situation where you made the t-step too small and you don't want to wait another 2 or 3 minutes for that to finish, just press second off, and then you'll notice the little yellow circle stop spinning. But until you press second off, you can't touch it, it won't do anything. Right? So second off, and then you can adjust it. Even 0.01, that's better, but you don't need that many points. I did 0.1 and I'm getting just as good of a picture when I did 0.1, I mean pretty much, as when I did that. You know? So it's about as good. Maybe you wouldn't have this little gap here at the end, because the smaller you make the t-step, the smaller that gap is. You probably couldn't even really see that gap that well. But there is a little gap. Now here, I didn't get it. I mean, maybe that looks just a little smoother, but was it worth waiting extra 50 seconds to dry it? I get the point with the one on the right. That's pretty good. Okay. Now, I told you I'd show you what happens if you leave this at 3. If you leave that at 3, you're not going to get the full circle. You didn't go through the full period of sine or cosine. So t didn't get to be all the values that it should have been allowed to be. So t is kind of important there. All right, so notice when you draw your circle, the domain was -2 to 2 on the x and -2 to 2 on the y. That was your domain. But the parameter had to go from 0 to 2 pi. I'm not going to show you, you can try it if you want, but if you go 0 to 4 pi, you would see the circle tracing over itself. And we don't really want to do that. We want to draw the picture as efficiently as possible, not drawing it twice. All right, so let's finish up with just looking at a few other different kinds of parametric graphs. Let's look at this one. So here's your two equations, and they look kind of similar to what we did before. But did anybody see what's different? It's t cosine t and t sine t. Yeah, you have an extra t in there. Where you're supposed to have a number here, it's a variable. And where there's supposed to be a number there, that's a variable. When you draw a circle, what does the number right here represent? The radius. Well, now your radius is a variable, meaning it's constantly changing. What kind of picture would you get if you draw something where the radius gets bigger and bigger and bigger? This is a spiral. So it starts as a small radius, and the radius, or the distance from the center to any point, it grows more and more as you spiral. Now, it's not going to spiral that many times. This tells you how many times it's going to spiral. Anyone think they know how many times it's going to spiral?
4.
Well, what's the period of sine and cosine? 2 pi, and this is going to 4 pi. So you have 2 full cycles of the spiral. What's that going to look like? Kind of like this. 1, 2. That's 2 revolutions of the spiral. Okay, let's try it. So we've got t cosine t, t sine t. 0 to 4 pi. Now, I've got to figure out how big to make my window. I want the spiral to go on the screen. So, look at cosine. Remember, when we drew sine and cosine, what's the highest and lowest that they went? They always go to 1 and -1. So this part right here, the biggest it could ever get is 1. What's 1 times 4 pi?
4 pi.
4 pi. So the biggest t can be is 4 pi. The biggest cosine can be is 1. Multiply the 2 biggest things you could ever have together, and that tells you how big a window you need. On the flip side, the smallest cosine can be is -1. -1 times 4 pi is -4 pi. So if you set a window -4 pi to 4 pi in every direction, you're good. Now, where you really need the most room is to the right. That's the part of the spiral that's the biggest. Okay? So if you do -4 pi to 4 pi, you're going to be covered. But you're going to have a lot of extra space on the top, a little bit extra space over here, and a little bit less right there. Okay? So you could make a tighter window than what I'm showing you. But let's just do it this way. -4 pi to 4 pi. -4 pi to 4 pi. Here's 1. And this will definitely stay on the screen. So I needed my x max as big as I made it. Could have made the y min a little, not that big. Could have made the y max a lot smaller. Could have made the x min a little bit smaller, but that's good. That's a start. Any question on that? Same deal. Make sure you set your t-step to a good value. This is not a good value. That's a really crappy looking spiral. Okay, so 0.1 is what you want. Let's finish up with this one. 5t minus 5 sine t, and 5 minus 5 cosine t. Now, you've got to be careful when you see t's outside of a trig function. This y part is very predictable, right? We just said earlier, what's cosine always between? Right, this is always going to be between 1 and negative 1. So let's look at those extremes, right? If cosine was negative 1, what's 5 times negative 1?
Negative 5.
And what's 5 minus negative 5? 10. So for y, you'll never get a value bigger than 10. It's impossible. You can't. Let's see how small we could go. If cosine is 1, what's 5 times 1? And what's 5 minus 5? 0. So your y values are going to be between 0 and 10. Because cosine is a very predictable function. This is going to cause us a problem. Sine is always between 1 and negative 1. So this part right here is always between negative 5 and 5. Has to be. 5 times 1 is 5. 5 times negative 1 is negative 5. I just did both extremes. So now you're basically going to take 5t and subtract the number between negative 5 and 5. Well, t is unlimited. They didn't give you a t min or t max here. So if t is 1,000, if your highest value for t is 1,000, that's 5 times 1,000, that's 5,000. Minus a number between negative 5 and 5. If t is 1,000,000, that's 5 times 1,000,000, that's 5,000,000, minus a number between negative 5 and 5. This part's predictable. I can tell you what's going to happen there. It's between negative 5 and 5. This part in the front, it gets pretty big. So we gotta pick a reasonable limit. Let's I don't know. Let's just try up to like 60. Okay, how do you know to try to 60? You don't. This is where you started learning how to use graphing calculators way back in the fall, and you just had to play with the window till you kind of got it. It's kind of what we're doing. Now, y's, those are good. They're always between 0 and 10. But x's can get pretty big. I'm letting x be 60. 5 times 60 is 300, plus or minus 5. So I should probably let my x values go to like 310, and let's see what happens. X min, I'm just going to put it at 0, and you'll see what happens. Did I type them in yet? No. So 5t minus 5 sine t, and 5 minus 5 cosine t, and watch what you got. Okay, that's awful. What do I have to fix there? Yeah, my step is really bad. It should look much smoother than that. Set your t-step to 0.1. Now you'll see what you should. And I went to 60. I mean, I could have gone higher or lower, but the point is you're just going to get that pattern repeating forever. It's just like a series of, like, I don't know, like hills or something. Right? So that's the graph you get. It just keeps cycling up and down and up and down. And because it just keeps repeating that cycling up and down, that kind of graph is called a cycloid. That's the name of it. So any graph that has this format is a cycloid. And if you say, wait, yours didn't look like that, well, yeah, it did. In our problem, A was 5. I'm going to put this back, but if you put a 5 in right there and distribute it out, 5t minus 5 sine t. It's exactly what I typed in for x. And if you make that a 5, 5 minus 5 cosine t. So that's the factored form of the equation I just typed in. I just factor out the 5s. And that's called a cycloid. Does anybody know what's special about that curve on a cycloid? Something special about it. Let's just take, I'm going to take and put that picture on the screen, but I'm going to make it larger. Because you need to kind of see this bigger. Okay. And I'm just going to draw one of these curves. Trace over it. Like that. All right, let's move that down here. Now, what I'm going to do with that curve is I'm just going to rotate it like this. Okay, what's special about that curve is, let's say you had like a platform up here, and you had a ball right there. And you want that ball to roll down a track and get to the bottom as fast as possible. The best way for it to do that is that curve right there, for it to roll down just like that. That's the fastest way it'll get to the bottom. You might think, well, couldn't you just put like if you had a surface and you wanted to get here, just put in a board, just have it roll right down the board? You could, but the curve of the cycloid, if that was the curve will get it there fast. It'll roll faster. That's what's special about a cycloid. So if you're building a roller coaster and you want to get the best amount of speed you can get when they're up here, down here, they should make the curve in the track of a cycloid and you'll go the fastest down it. Okay? If they make it straight, you won't go as fast. That's why a lot of roller coasters, they're curved. Okay, so homework tonight, a lot of it's on the calculator. So anything you do on the calculator, you just put on the calculator, that's fine. But it's 1 through 5 odd. And then 7, 9, 11, 15, 17, 21, 22, 25, and 29 to 32.